Hello students, good evening. Welcome to another video of Vedantu Karnataka. This is Catherine, your physics master teacher. Can you quickly let me know if I'm audible and visible? Am I audible and visible? Hello Rakshita, hello Sharmila, hello K Manoj, hello Santosh. I think I'm audible and visible. Can you please confirm? Good evening, Chinni Ammu. Okay. So, yes, as you've all seen the thumbnail, we're going to start with first PUC portions. All right. So, from now on, we'll be doing a series. We'll be doing all the chapters of first PUC physics. Okay. So, I want all of you to keep supporting, keep watching the videos, keep learning. Okay. So, we'll all learn together. So, send this to all your friends, all those who have joined for first PUC, tell them to follow all the lectures. Okay. Now, students, if any of you want offline classes for KCET, for NEET, for JEE, for 8th to 10th foundation, for whatever, okay, you can always visit our JP Nagar, Bengaluru, the offline center. So you can see the address. Okay, you can take a screenshot quickly and go visit our center. So even if you are doubtful on if you should join or not join, just go visit the center, talk to everybody there, and then you can decide. Okay, but please do go visit the center. Yeah. Okay, we're all telling you this because we're very confident about the offline center, and I'm sure it will help all of you. I teach physics. Okay. Yes, Suchit, what help do you want? Hi Pujit, hi Monster, hi Rakshu. Okay, so let's start. So we are going to learn the first chapter, which is units and measurements. Okay, are you all ready? All my first PU students, are you all ready? Yes. So first thing that you will learn in this chapter is physical quantity. Now, what is a physical quantity? I tell all of you, you're all my students and I trust all of you. Is that a physical quantity? Yeah? No. A physical quantity is a quantity that can be measured. Okay? For example, 1 kg of rice. I can measure that. That is a physical quantity. So, mass, the length of this pen, I can measure it. So, length is a physical quantity. Right now, my body temperature, I can use a thermometer, I can measure it. So, that is a physical quantity. But, my emotions, if I'm feeling sad now, I don't have a meter that can measure how sad I am, right? You can't measure how sad you are or how happy you are. Right now, I'm very happy because I'm teaching all of you. Yeah. So you can't measure those things. So whatever you can measure, any quantity that you can measure is called a physical quantity. Okay. Now, what are the examples? Length, mass, time, temperature, all of those are physical quantities. Okay. Hi, Monster Gang. Hi, K Manoj. Okay. Now, every physical quantity has two parts. Okay. First part is the value, and second part is the unit. For example, as I said, I have 1 kg of rice. Okay. So, this 1 kg is my physical quantity. It gives you the weight of the rice. So, 1 kg has two parts. First part is the number. It is the value, which is 1, and then the unit, which is kg. Now, if I say this pen is 15 centimeters long, okay, so I say this pen is 15 centimeter long. So, 15 is the numerical value, and centimeter is the unit. Okay. So if you look at a physical quantity, it has two parts. The first part is the numerical value. The second part is its unit. Okay. Yes. That's about physical quantity. Hi Kushala, I'm good. How are you? Now let's move on. Next, we saw that physical quantity has two parts. It has the numerical value and the unit. What is a unit? So, you know kg is a unit, you know centimeter is a unit, you know meter is a unit. But in general, if I ask you what is a unit, what will you say? You'll be like, ma'am, it is something that is there and behind every number. No. Okay. What is a unit? A unit is an internationally accepted standard of measurement for a physical quantity. What does that mean? That means, for example, just let's take the same example for everything. 1 kg of rice. Okay. See, even if I buy 1 kg rice from India, and somebody else buys 1 kg of rice from Canada, another person buys 1 kg of rice from, let's say, Australia, the amount of rice all of us get is going to be the same, isn't it? Because we all bought 1 kg of rice. So the unit kg represents the same thing in all parts of the world. So that is the importance of unit. Okay? Unit is an internationally accepted standard of measurement. So if, it makes every physical quantity uniform. So if I say my temperature is 27 degrees Celsius, a person somewhere else, if he measures his temperature, he measures it in degrees Celsius, he's going to measure the same way just like I did. Okay, so they are standard values or standard units. They're accepted internationally. Now, some common examples of units are meter. Meter is the unit for length. Second is the unit for time. Why is a unit important? To make everything uniform, right? Because, it has physical quantities have to be uniform. See, if my mass is 50 kilo, my weight is 50 kilograms. Okay, it should be the same wherever I go, right? Because kilograms is a standard unit. Now imagine a unit is not there. On my mass, my weight balance, I say it's 59. Someone else uses some other, measurement method, and he says it's 100. You can't compare, right? So that is why units are very important. So let's look at the importance of units. Measurement is a comparison with a standard time. Standard unit. So you can compare. So I can compare my mass or my weight with a person in New Zealand. Why? Because both of us have our weights in same unit. So we can easily compare. Okay. The unit must be of the same type as the quantity measured. For example, if you're measuring length, the unit should be meter or centimeter. I can't say this pen is 3 kilogram long. This is always 3 centimeter or 3 meters long because this is the length. Okay? Okay. Yes, Ammu, very good. Students, Kannada, I'm trying. Okay, but I'm not that fluent in Kannada. I'm really sorry, but okay, I'll try to go slowly in English. Okay? Now, there are two types of units. Okay? The two types of units are, the first type is fundamental unit. Okay? The second type is derived unit. Okay? So, what are the two types of units? You have fundamental unit and you have derived unit. Fundamental unit is the units of basic quantities. For example, just like I said, pen. Pen, the length of the pen is measured in meters or centimeters. It is a fundamental unit. My temperature, I measure it in degrees Celsius, Kelvin and all. Mass, I measure it in kilograms, grams. So fundamental units are units of fundamental quantities or basic quantities like length, mass, time and all that. The unit of time is seconds. It is not derived from anything else. But what is a derived unit? A derived unit is where you find out the unit. For example, let's say speed. Okay, what is the formula for speed? Speed is distance by time. Okay, so distance is a fundamental quantity. It has a fundamental unit, meters. Time also has a fundamental unit, second. But the unit of speed is what? Meter per second. Right, the unit of speed is meters per second. So per means divided by meters per second. So this is a derived unit because the unit of speed is derived from the unit of distance and the unit of time. You understand the difference? So fundamental units are units of basic fundamental quantities. Derived units are formed by combining the fundamental units. Okay? Now together they make up the system of units. Alright? So just like I said, this is a little more, I've given you some examples of some fundamental units. Okay? What are the fundamental units? Length, mass, time, temperature, electric current, luminous intensity, amount of substance. These are all fundamental units. Why? These cannot be derived from anything else. Isn't it? Yeah. See, meter is meter. Kilogram is kilogram. These are all units that are independent of anything else. You cannot break down these units. You cannot, these are like the basic units. Okay. An example of a fundamental unit is what we measure. Like, for example, how tall a child is. Okay. So, the height of a child, we can measure it in meters, we can measure it in centimeters. And both these meter and centimeter both are fundamental units of length. Okay. The height of a child, meter, centimeter, both are fundamental units of length. Yeah. Okay. Yes. So I have given you a table here. Okay. Same thing that I put in the previous slide, but this is for your understanding. When I share this PDF, you can refer it. So I have the fundamental quantities. I have their symbols. Okay. So for length, the symbol is L. For mass, the symbol is M. Time, the symbol is T. Temperature is capital T. Okay. So students, please don't get confused. Symbol and unit, they're two different things. Symbol is just an abbreviation or a short form for the actual quantity. For example, length, I represent it as L. But what is its unit? Unit is meter and the symbol of the unit is M. Do you understand that? Now mass, instead of mass I can write it as capital letter M. The unit of mass is kilograms. In symbols it is kg. Okay. Time, I can represent it as small t, but its unit is second. The symbol for its unit is S. Temperature is capital letter T. The unit is Kelvin. The symbol for the unit is K. Similarly, electric current, you can represent it with the alphabet I. Okay, electric current is not E. In your textbooks, in your first PU and second PU or CBSE, whatever you learn, electric current is always represented by the alphabet I. Now you might be asking me why these symbols are important. That's because when you write an equation, you will not write mass as MASS. You will just put it as capital letter M. You will not write current as electric current. You will just write I. For example, in your in the next chapters, you will learn P is equal to VI. So this formula means power is voltage into current. So you need to know I stands for current. See, all these you don't have to by heart, students, because you will do a lot of this. This will stay in your head. Okay. The unit of current is ampere. The alphabet representing the unit is A. And the luminous intensity is candela. Amount of substance is mole. Okay. So these are all fundamental quantities and fundamental units. Next is derived units. So derived units are units that are formed by combining two or more fundamental units, as I already showed you. So speed is distance by time. So if you combine the unit of distance and the unit of time, you will get the unit of speed. Okay. So derived units are used to measure quantities that are not fundamental. You can't measure the fundamental quantities like speed, force, volume. All of those are quantities that are formed by basic quantities like length, mass, and time. Okay, so here there are some examples. Speed, the unit of speed is meter divided by second. So it is formed by two fundamental quantities, meter and second. Next is force. So the formula for force is mass into acceleration. Now, the unit mass is a fundamental quantity. The unit of mass is kilogram. Acceleration is not a fundamental quantity. Acceleration is velocity by time. Now, what is velocity? Speed into time. So this is speed. Okay, I'm not going to that much basic. So here the unit would become, mass is a fundamental quantity. So its unit will be kilogram. Velocity will be meters per second. Time will be second. So in total this becomes kilogram meter per second square. So you can see force is derived from so many fundamental quantities. So it is a derived quantity. Next you have area. Area is what? It is from two fundamental quantities, which is length and length. So meter into meter, meter square. Now what is volume? Side into side into side, or length into breadth into height. Meter into meter into meter, which is meter cube. Density is kilogram per meter cube. So density is mass by volume. See, I will write the formulas using symbols. So what is the unit of mass? Mass is a fundamental quantity. So the unit is kilogram. Volume has a unit meter cube. So this is kilogram per meter cube. Okay. Okay. Yes. Now students, this is quick exercise for all of you. Write the SI units of the following quantities. Okay. I want you all, after the class, you can just take a screenshot of this. You'll have the questions in my head also. But you can take a screenshot and then you have to solve all this. Okay. Yes. Those who are watching it online, those who are not watching the live, please pause the video, solve all this, and then let's move forward. Okay. Done? Okay. I think you're done. Let's move on. Now, next question. Write the SI unit of the following derived quantities. So, speed I've already done. You will get meter per second. Force also I've done. Area also I've done. This is just, a small brain test for you to practice. Okay? Homework. All of you, the answers are already there in the previous slides. So, this is just for you to test your memory. Quickly take screenshot or pause the video, solve it. Yes? Okay. Yeah, one answer I've given here. The rest answers you can easily get. You're all smart students. Okay, so that much is clear to you. We discussed about the two kinds of units, fundamental units and derived units. Next is system of units. So what is a system of units? A system of units means it is a set. A system is a set, okay? It is a set of units that is used to measure physical quantities. So imagine you have length, mass and time, okay? Now for length, the unit could be meters. For mass, it could be kilogram. For time, it could be second. So these three together forms one system of units. So there are so many systems of units which are given here. So the first system is what it's called the FPS system. FPS stands for foot, pound and second. So that means if you measure length in foot, mass should be in pounds. Time should be in seconds. Next is the CGS system. So in CGS system, if centimeter is if you measure the length in centimeter, okay, let's take this pen. If I measure the length of the pen in centimeter, I should measure the weight of the pen in grams. I should measure the time taken for the pen to do something in seconds. Okay. Next is the MKS system. What does MKS represent? Meter, kilogram, second. This is the standard one as well. So if you measure the length in meters, the mass should be in kilogram. Time is anyways in seconds. Next is the SI, which is the System International, which means it's similar to MKS. If you measure mass in meters, you measure weight in kilogram, you measure time in second. Students, when is this important? This is very important when you do numerical problems. Okay, so imagine you get a question. A student, okay, let's take the pen itself. Okay, the teacher is writing with a pen of 5 centimeter, which weighs 20 kilogram. Okay, so length of 5 centimeter and it weighs 20 kilogram. They ask you to find out something. Okay, but you cannot solve it in this way. Why? Because centimeters and kilograms are in two different sets of units. Okay, if you take 5 as centimeter, what should the unit of mass be? It should be in grams. Or what you should do, since mass is kilograms, you should change your length into meters. So this should either be 5 centimeter and 20 into 1000 grams. Or this should be 5 divided by 100 meters and 20 kilograms. Do you understand that? So that's how you should convert. So you should, whenever you get a question, you should look at the units. Either they should be in MKS or they should be in CGS. But it's always good if you can do it in the MKS, which is a standard system. So make sure all the quantities are in their SI unit. Alright? Yes. Okay, so this is why units are important. Okay, now we looked at units, right? Now we looked at the last unit was International System of Units, which is the SI unit. So that is the most important one, and that is the internationally accepted standard unit. So that is what we are going to learn. Those units are what we will be using mainly in your whole physics life. Okay, so you usually will use that unit, but there are cases when you use other units as well. Now, SI units are the standard accepted units, and there are 7 basic fundamental quantities and their SI units, which I have given here. This by this time you should be able to know by heart, because I've been discussing the same thing for like, what is the time now? 20 minutes now. Yeah. So you have length, mass, time, temperature, current, luminous intensity, and amount of substance, and their units. These are the SI standard units. Okay. Now, other than these fundamental quantities, derived quantities, all this we learned, there are 2 more different types of quantities which are called supplementary quantities. Okay? What are supplementary quantities? Supplementary quantities are neither fundamental nor derived. Obviously, that is why they come under another category. Right? So, if you have something, you have good, you have bad, you have okay. Okay, let's say those are the 3 categories. Something that is not that great or that bad, you put it in the okay category. Okay, just like that, something that is not fundamental nor derived, you put it under supplementary quantities. So what are the supplementary quantities? Supplementary quantities, they have no dimension. Okay, now you might be thinking, ma'am, what is dimension? Relax, I'll tell you. Okay, towards I'll teach you that today. So what are supplementary quantities? They are not fundamental, they are not derived. There are only 2 supplementary quantities that you need to know. They are plane angle and solid angle. So imagine you take a circle, okay? You cut a small part of the circle, and this is at an angle d theta, okay? Now to find out the plane angle, you just take theta to be this arc length by radius. Okay, that is going to give you your plane angle. Theta is arc length by radius. Now, next one is solid angle. For solid angle, same thing, but you take a whole sphere. So, when you take a sphere and you cut a small portion. So, instead of a single, this thing, you get a 3D version. So, you take a sphere, you cut a small portion, and that angle is called a solid angle. So, this is given by this area of the surface divided by the radius square. Okay? Cool. Yes. Now, why they are not fundamental or derived? Because they do not depend on any physical quantities like length, mass, time. See, what is a fundamental quantity? A quantity that is like length, mass, and time. It cannot be broken down. It's the basic most quantity. Now, what is a derived quantity? Any quantity that depends on these fundamental quantities like speed, force, and all. But solid angle and plane angle are quantities that do not come under fundamental. They are not derived from fundamental. So, you name them as supplementary quantities. Okay, so they are kept separate from both fundamental and derived quantities. Okay. Yes. Are you following the students? Yes? Or am I just talking to a screen? Can you all quickly let me know in the chats if you're following the class? And if you're following the class, please put a like, okay? Mark your attendance. All of you go like the video and subscribe to the channel, okay? So that we can keep giving you content like this. Yes, that's the only thing that we want from you. Let me know in the chat how the class is. Like the video, subscribe to our channel. What is happening in the chat? What's the discussion? Just slow. Am I stuck? Okay, Pujita has given me thumbs up. Pritu gives me thumbs up. Alright, next. Let's look at the conversion of units. Okay, so we already saw that a physical quantity has what? It has a numerical value and a unit. Now, as I said, each pair, if it's not, if mass, time, and length, if all three are in three different units, you have to convert them. So let's look at an example. So the question is to convert 10 meters to CGS system. Okay, so I have to convert 10 meters to CGS system. How do I do that? I have to convert 10 meters to dash centimeter, because in CGS system, what is the unit for length? It is centimeters. Okay. So 1 meter is 100 centimeter. So 10 meters will be 10 into 100, which is 1000 centimeter. So here the answer will be 1000. Okay. Yes. Okay. See, you can see that the physical quantity is what? Length. That remains the same. Okay. So, value and unit both will change. You can see the value becomes from 10 to 1000. Unit changes from meter to centimeter. But both these represent the same thing. So, imagine it is, this is too big to measure, to represent the length of the pen, but still. If I say this pen is 15 centimeters, if I convert it into meters, it becomes 0.15 meters. Both are the same. They both represent the same pen, but they have two different units. It is meter and centimeter. It is also different numbers, but they represent the same thing. So that is what I've written here. The physical quantity remains the same, which is length itself, but the value and unit both will change. Okay? Okay, next question is to all of you. Convert 5 kilograms to grams quickly. So here we're going to use a small formula to do it. So this formula is something that you can use in your initial stages, but when you're doing your KCET, NEET exam and all, you don't have to look at these formulas because you'll be experts by then. Okay? If you keep following our classes, we'll keep giving you content for KCET, NEET and all that. So by the time you finish all the series, you'll be experts in all these basic stuff. Okay. So let's use a formula. What is my formula? My golden formula. N1U1 is equal to N2U2. Okay. So I have to convert 5 kilograms to some grams. So N1 is my quantity. So N1 is 5. U1 is kilograms. Okay. Now this is equal to N2. I don't know. So I'll put it as N2. U2 is I have to convert it into grams. Okay. Is this much clear? I know I have to convert 5 kilograms to grams, but I don't know how many grams it's going to be. So it becomes 5 kg equals N2 grams. Now, 5 into simply kg means what? It means 1 kg is equal to N2 into gram also means 1 gram. So 5 into 1 kg is basically 5 into 1 kg is how many grams? 1000 grams. Okay. 1 kg is 1000 grams is equal to N2 into 1 gram. Now 5 into 1000 is 1, 2, 3. 5000 grams is equal to N2 grams. So, if you are, what I can do is 5000 divided by 1 gram is equal to N2. So N2 is basically 5000 grams. Is this confusing? We will do one more question like this. Okay. I think I have one more question. I don't. Okay. Since I don't, I will make a question now. So let's say, let's take length. Okay. 500 centimeters convert to meters. Again, formula. N1U1. Wait. 500 meters I'll convert to centimeters. Yeah. N1U1 is equal to N2U2. How much is N1? 500. U1 is meters. N2 is I don't know. I have to find out. U2 is centimeters. Okay. So this is 500 into 1 meter is equal to N2 centimeter. 500 into 1 meter is how many centimeters? 100 centimeter is equal to N2 into 1 centimeter. Now, 500 into 100 centimeter divided by 1 centimeter is equal to N2. So, this becomes 5, 1, 2, 1, 2 centimeters is equal to N2. Okay. Yeah. Now those who don't like to do steps, you can directly write. How will you directly write? 500 meters is equal to dash centimeter. 1 meter is 100 centimeter. So 500 meters is 500 into 100 centimeter. You can use this as well. Okay. You can use however you want to do it. Now, if you want to convert it the other way around, what will you do? 500 centimeter is equal to dash meter. So 1 centimeter is how many meters? See, 1 centimeter is a small amount. This is definitely not equal to 100 meters. It is equal to 1 by 100 meters. So 1 by 100 meters. So 500 centimeters is equal to 500 into 500 centimeters will be what? How will you convert 500 centimeters to meters? You have to tell me. So 1 centimeter is 1 by 100 meters. Yeah. So 500 centimeters is 500 by 100 meters. So 0 zeros cancel. This is 5 meters. You can do it either however you want to. Okay. What is happening in the chat? Okay. Yeah. Now I'll tell you some trick to remember if you should multiply with 100 or divide with 100. I've seen so many students. One major confusion they all face is, ma'am, meter to centimeter, should I multiply with 100 or divide by 100? Centimeter to meter, should I multiply or divide? So this is what you should know. Okay. So the trick is, bigger the unit, smaller the number. Okay. So if you have two units, meter and centimeter, which is a bigger unit? Meters. So if you have two numbers, 5 and 500. So the smaller number should go to the bigger unit. 500 should go to the smaller unit. Bigger the unit, smaller the number. Smaller the unit, bigger the number. Yes. See, it's just like filling a bottle. Okay. See, if you fill water in mugs, it'll fill faster. But if you fill it in spoons, you need a lot of water. So spoon means small unit. You need a lot of values. Mug is big unit. So you need very little water. Okay. I mean, time to fill the water. Okay, not the amount of water. Another thing you can remember, another trick you can reduce is the value is always proportional, inversely proportional to the unit. So which means if value increases, unit should decrease. Right. So if from 5 it goes all the way till 500, unit should be from meter, it should decrease to centimeter. Or it should go on. So if the value becomes bigger, the unit should become smaller. If the value becomes smaller, unit should become bigger. Okay. For that you should know which is the bigger unit. So for example, millimeter is the smallest unit of length. Then you have centimeter, then you have meter. So millimeter will have the biggest value. Centimeter will have next. Meter will have the smallest value. Okay. So let's say for example, 10,000 millimeter is how many centimeter? Divided by 10 is 1000 centimeter. Is how many meters? It's only 10 meters. Okay. So that's how bigger the unit, smaller the value. Yes. Okay. Now these are some units. So all those who are preparing for entrance examinations, otherwise also it's good if you can know these. But majorly for those who are going to prepare for your entrance exams, you will have to convert giga, mega, kilo, hecto and all to meters and all that. So for example, they tell you the length is 9 into 10 raised to 9 gigameters. So what you have to do, this will be 9 into 10 raised, okay, no. What did I do? So the question says the length is 9 gigameters. So what you should do, it will be 9 into 10 raised to 9 meters. Or let's say the power is 6 megawatt. So this will be 6 into 10 raised to 6 watts. So that's how you convert. Now if you want to convert the other way around, what will you do? 6 watt will be 6 into 10 raised to minus 6 megawatt. Okay? So that's how you do it. Now all of these units you can convert accordingly. If it's hecto, it means 10 raised to 2. Deca is 10 raised to 1. Now, deci is 10 raised to minus 1. Centi is 10 raised to minus 2. Milli is 10 raised to minus 3. See, these are all with respect to meter. So, let's say milli means 10 raised to minus 3. What does that mean? 1 millimeter is 10 raised to minus 3 meters. Now, 1 nanometer is how much? 10 raised to minus 9 meters. 1 micrometer is 10 raised to minus 6 meters. Okay? So that's how the different units are. Okay, quick question for all of you. Pause the video and solve it quickly, all of you. So not to those who are watching live, but the others. Later if someone watches this. Convert 50 kilometers per hour to CGS units. So how will you convert 50 kilometers per hour to CGS? 50 kilometers per hour is going to be what? Some dash. CGS will be kilometer in CGS will be centimeter per second. Because C stands for centimeter. G stands for gram. Here no mass, so no need gram. S stands for second. So how will you do that? You can use the formula N1U1 is equal to N2U2. I've already solved it, I think. Yeah, I've already solved it. So let's just do it once again. So N1U1 is equal to N2U2. So N1 is how much? 50. U1 is kilometers per hour is equal to N2 into centimeter per second. Okay. Now, to convert kilometers to centimeters, let's do that. So, 50 kilometers is 50 into 1000. 50, 1, 2, 3,000 meters. Now, to convert that into centimeter, it will be 50, 1, 2, 3 into 1, 2, 3 into 100, right? So, 100 centimeter. Now, to convert hour, 50 hours to seconds. This is going to be 50 into 60. 50 hours is 50 into 60 minutes into 60 seconds. So this is going to be 50 into 3600 seconds. Okay? Hello, Praveen. So that conversion I've given here. Alright? So now let's substitute that in our formula. Let's do the substitution. Okay. Okay, let's do the substitution. So 50 into, instead of kilometer per hour, I can write this quantity. 1, 2, 3, 4, 5 divided by 3600 centimeter per second. Okay, this is going to be equal to N2 centimeter per second. Yeah, that is the step. So 50 into, instead of kilometer per hour, I converted into centimeter per second. So now what is N2 going to be equal to? 50 into 1000 by 3600, you will get 138988.9 centimeters per second. Okay? So you have to be quick in math. So here, I think I should put 1 itself. Otherwise, you might be very confused. You'll be like, ma'am, 50 there, 1 here. What is happening? 1000 meters, 1, 1, 1, 1. Okay. Next, Kushala, half an hour more here. Not more than that. Okay. So next is the most important part. Okay. So this is, you will get for sure questions from dimensional analysis. Okay. Even in your PU exam and in all these competitive exams, there's always a sure question from dimensions. So what is dimension? Hey, the name. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent that physical quantity. So here I've put the exact NCERT definition for those of you who want to learn it in the PU perspective. So the dimension is basically defined as the power to which a fundamental unit has to be raised. So you might have been wondering, what is this man saying? So I'll show you an example. So the basic dimension physical quantities are mass, length, and time. Okay? Yes. Yeah. Mass, length, and time are the basic physical quantities. Now, I'm going to tell you whatever derived quantities you have, you can write it in terms of mass, length, and time. Mass will be raised to some A, length will be raised to some B, time will be raised to some C inside a square bracket. So, this formula is called dimensional formula. Okay. Now, A, B, C value depends on different kinds of quantities. I will show you how that works. So, let's look at this. First one is speed. Okay. So, let's find out the dimension of speed. Okay. Hi, Pallavi. How will I find the dimension of speed? First, I will write the formula of speed. What is the formula of speed? Speed is distance by time. Now, what is the dimension of distance? Distance is nothing else but length. So, the dimension of distance is length, and it's just length, not length square or length cube. So, L raised to 1. Divided by what is the dimension of time? T. Okay, it's not seconds. The different dimensions are, I'll show you. So, time is also just raised to 1. So, this becomes L T raised to, when time goes up, it becomes minus 1. Now, what about mass? M raised to 0. Why M raised to 0? Because there is no mass. See, this is how you write a dimensional formula. So, the general formula was M raised to A, L raised to B, T raised to C. So, M is not there, so M raised to 0. There's only one length, so L raised to 1. And time was in the denominator, so when T goes up, T raised to minus 1. So, A, B, C are 0, 1 and minus 1. Square bracket is very important. If you don't put the square bracket, you will get 0 for your PU exams. Okay. So these are the different dimensional formulas, alright students. These are different from your SI unit. This is dimensional formula. For length, it's capital letter L. For mass, it's capital letter M. Time is T. Current is A. Temperature is K. Amount of substance is mole. Luminous intensity is CD. Most important thing, the three dimensions M, L, P. Mass, length, time. Okay, put that in your brain now. Three dimensions. M, mass. L, length. P, time. Inside square bracket. Okay? Yes. So that's how you find out the dimension formula. Let's do another question. Acceleration. Okay. Next, find out the dimension for acceleration. So first step, write down the formula. Formula is velocity by time. Now velocity is distance into time or displacement into time by time. So I should write down the formula in terms of fundamental quantities because I only know dimensions for fundamental quantities. Now distance has a dimension of L, time has a dimension of T, LT. The whole divided by, again, time has a dimension of T. Now what happens? L, T, and then when the other T comes up, it becomes, oh, this is distance by time. Make a small eraser. Here this is not into, right? Velocity is distance by time. So this is T raised to minus 1. Okay. So when T from the denominator goes up, what happens? T raised to minus 1. From the denominator it goes up, there is one more minus 1. Okay. And then how much would M be? M raised to 0. With bracket. Without bracket, you will not get any marks. So what is the final dimensional formula? M raised to 0, L raised to 1, T raised to minus 2. This is the dimensional formula for acceleration. Okay. Yes. See, NCRT is, the portions from NCRT is more than enough to crack NEET, but you need to know to apply them. You need to practice lots of questions. Okay, students. So for NCRT, only just by studying the concepts in NCRT, you will not be able to crack NEET. You need to solve problems. You need to apply. You need to, think in a higher level, the application part of NCRT. But portions are only NCRT. Okay. So all those who need help in NEET, JEE, KCET, whatever, you can always, it's always good if you can go to offline centers because they will, give you individual attention. So we have an offline center at JP Nagar. All those are from Bangalore or Karnataka. We have an offline center at JP Nagar. If you watch the starting part of the video, I have the address there. You can go visit them. Obviously, in YouTube also will be helping you, but in YouTube, I cannot, individually monitor all of you because I can't see any of you, right? So if you go to an offline center as well as watch YouTube, it will be very helpful for you. Okay. Somebody else also said something. See, all of you spamming the chats. I'm not able to see, important messages. Bye. Good night. Ma'am, could you how to keep those basic? Ma'am, could you please teach me how to keep those basic quantities and units definition? Dear, basic quantities are which all? Length, mass, time. I already showed you the table, right? That table you study properly. You write and study. Length, meters. The dimension is L. So this one table, you study properly. Okay, so what you can do is for the first time when you study it will be confusing. It has to be, okay? Physics is like that. Even when I was a student, it was very confusing for me. So what you do is you draw this table in your book. You draw this table at least 3 times. So then it registers in your mind. The next time it will be very easy for you. Only first time it will be confusing. Okay? And just because it's confusing, please don't skip it. Okay? These are all very important things and very simple stuff. You can score easily for all this. Okay? So right now we're not late. We're just starting. You have only started your first PUC. You have a lot of time. That is why we're doing videos so early so that you can take your time and study. Okay. Now let's do one more dimension. Let's do pressure. Okay. So find out the dimension of. No problem, Gojo, Rakshita. So send this to all your friends. Okay. Put it in all your PU groups, your unofficial groups. And then tell them to follow these videos. I'll be doing videos on every chapter. Okay? Yeah. Students, when you watch lectures in school, it's just a one-time lecture. You can't go back and watch. So that's why we have YouTube. You can always go back and see what was said earlier. Yeah? So make use of all of these facilities that you have. When we were students, we didn't have all of these facilities. We had to learn from an offline teacher only, which was also good. I'm not saying offline teaching is bad. It's also good. But this is like an additional help for you. That's all. Okay. So pressure, I'll find out the dimension formula. First, I will write down the formula for pressure. So let's say Okay, you might not have learned. Have you learned the formula for pressure now? You will learn it anyways in this, but then you should have, no? Pressure and all is basic formula. Anyways, those who have not learned the formula, you will learn it this year, okay? So pressure is force by area. Okay. Force is not a fundamental quantity. Area is not a fundamental quantity. So we have to simplify the formula even more. So what is force? Now force I can write it as mass into acceleration. The whole divided by area. So mass is a fundamental quantity. So I don't have to, keep deriving it more. So this will be mass has the dimension m. Acceleration is what? Acceleration is velocity by time. So this is velocity by time. The divided by area is what? Length into length. So the dimension for area will be L square. So this is mass into dimension for acceleration. If you know the dimension for velocity, you can just write it like this. Dimension for velocity is Lt raised to minus 1 divided by t, the whole divided by L square. So this will be ml t raised to minus 2 by L square. This is m, L goes up, L raised to minus 1, t raised to minus 2. Okay, m, L raised to minus 1, t raised to minus 2. Now for those of you who didn't know, okay ma'am, how did you get Lt raised to minus 1? Those who don't know, you need to know formulas, only then you can do dimension. Those who don't know for velocity is what? Distance by time. So this is L by t, which is Lt raised to minus 1. That is what I have put here. Okay. So this is how you determine dimensional formulas. Okay, students. Okay. Let's move on. So these are some dimensional formulas for different physical quantities. I have put all of their formulas also and how I get them. So work done is force into distance. Force is mass into acceleration. So you can work these out. Okay. So whenever you have time, you can work these out. If you have doubts, you can always put it in the comment section. Probably in the next class or some class, we will figure it out. Okay. Now this is how you will get questions. Force acting on an object is given by F is equal to ma. Find the dimensional formula of force. So you have to substitute and find it out. I hope this is clear to all of you now. So for those of you who still have doubts, you can go back. Okay, I have solved 3. So solve each of it by yourself. Keep solving it. Go back if you still have doubts. If you watch it like 2 to 3 times, you will definitely be an expert. Okay. There's a question for kinetic energy also. Okay, I will do this one also. So I have to find out the dimension for kinetic energy. What is the formula? Half mv square. Okay. So students, constants or numbers you can ignore when you're doing dimension. You don't have to consider. So you have to find out the dimension for mass and velocity square only. What is the dimension for mass? M. What is the dimension for velocity? Distance by time. Distance is L divided by time. So t raised to minus 1 square. So this becomes m L square t raised to minus 2. That's all. Half you can ignore. Okay, in dimensions, even if you have half or 5, any number, any constant, you just ignore. But powers, you can't ignore. Powers you have to put. Okay. Okay. Next is some quantities do not have dimensions. Okay. So quantities like refractive index. Why don't they have dimension? Because they have no unit also. So refractive index is what? Speed of light in vacuum or in a medium. Speed of light in vacuum divided by speed of light in a medium. Okay. So they both have the same unit, meters per second and meters per second. So they cancel out. They have no unit. So they have no dimension. Okay. So such quantities are called dimensionless quantities. Not every quantity has a dimension. Okay. Next is the first principle of dimension. It's called as the principle of homogeneity of dimensions. So in your PU, you can get questions. Explain the principle of homogeneity of dimensions. So that means that quantities with the same dimension can be added, subtracted, or equated. Okay. So what all can be added, subtracted, or equated? Quantities that have the same dimension. I'll give you a very easy example. I'm telling you, my pen has a length of 5 centimeters. You'll be like, man, we're tired of your pen. Okay? Okay. Let's say my glass has a length of 5 centimeter and it has a weight of 50 grams. Okay? Can I add this two? Can I add these two? I cannot add them because they are quantities with two different dimensions. What is the dimension of 5 centimeter? It's L. What is the dimension of mass? It's M. So you can't add these two. I can't add 5 centimeter and 50 grams. Okay. So that is principle of homogeneity. Quantities with same dimension can be added, subtracted, or equated. Now if it is 5 centimeter and 50 centimeter, you can add it. Imagine this is 5 centimeter and 50 centimeter. You can add it, it becomes 55 centimeters. Okay. If they have the same dimensions, you can add them, subtract them, multiply them, whatever you want, you can do. Okay. Hello, Movika World, I remember you. How was your exam 3? Will you pass? Okay. So the left hand side and RHS of a physical equation must have the same dimensional formula. That is also another rule. So let's look at an example. Okay. Okay, let's look at an example. So S is equal to UT plus half AT square. This is an equation of kinematics. You might have already learned this in your school or your PU college. Okay, so this is the formula. So for this to be a dimensionally correct formula, S and UT plus half AT square both should have the same dimension. So you'll be like, ma'am, S is a single alphabet. How can it have the same dimension as UT plus half AT square? It should. Only then the equation will be correct. Let's prove it. So what is the dimension for S? Its length. So this is L is equal to dimension for U and T. U is what? Initial velocity. Velocity has a dimension LT raised to minus 1. Time has a dimension T. Plus half you can ignore. You don't look at constants. Acceleration has a dimension LT raised to minus 2 into T square. Now when you equate this, both of these cancel, both of these cancel. So this final equation becomes L is equal to L plus L. So all the quantities have the same dimension. So this, all terms have dimension L. So the equation is dimensionally correct. Okay. So that's how you work it out. Yes. Is this clear? So that is the rule. So the left hand side and the right hand side should have the same dimension, and only if you have the same dimension you can add, subtract, multiply and do all of that. So this is some basics on dimension. Is this clear to all of you? Okay, Movika World, you will get very good marks. I will get good marks in exam 3 of second PUC because of you, ma'am. Thanks a lot. Welcome. Okay, I'm very happy to hear that. I looked at comments, you all told me you'll comment if exam 3 was easy, but none of you commented. Only I forgot his name, but I know him. Only he commented. Where's your comment, Movika World? There were so many in my exam 3 class. They said they will recommend this channel to their friends if exam 3 is easy. None of them are seen now. Hi, toxic. Are you really toxic? Okay, let's move on. So you can get so many questions like this. Check the dimensional correctness of V is equal to U plus AT. Let's do that also. V is equal to U plus AT. Okay, so V is final velocity. The dimension of final velocity is LT raised to minus 1. U is initial velocity. It also has the dimension LT raised to minus 1. Plus, acceleration has the dimension LT raised to minus 2. Time has the dimension T. So this becomes okay, toxic. You can put whatever you want. I know none of my students, all my students are very good students. So T raised to minus 2 into T is what? T raised to minus 1. So you can see all three terms have the same dimension. So they are dimensionally correct. So you have to write that. Okay, all those who are preparing for PU, you have to write all three. What was the word? All three terms. Yes, sometimes I also forget. All three terms have same dimension. So the equation is dimensionally correct. Okay. Yeah, I've solved that question here. Okay, I've solved one more question here. See here also students, this 2 pi is a constant. So constants should be ignored. Okay, you don't have to consider constants when you are doing dimensions. Okay. Yeah, I know toxic. They're all toxic, no? Now, another kind of question set that you can put is check whether the equation half mv square is equal to mgh is dimensionally correct. Let's do that. Now we're confident we can do anything. So half I ignore. Mv square. The dimension of mass is m. The dimension of velocity is lt raised to minus 1 square is equal to mgh. Okay. So mass is m. So students, you might be asking, ma'am, what is the dimension for g? G stands for acceleration due to gravity. So it has the same dimension as acceleration. H is height, which is a length. Okay, so let's say this becomes ml square t raised to minus 2 is equal to ml square t raised to minus 2. Very good. So this equation is dimensionally correct. Yes, Praveen. Yes, it's dimensionally correct. Okay? It's okay, toxic. You listen to the class. Okay? And you send this to your friends. Let them also listen to the class. So don't listen, it's okay. If at least one student listens, that's more than enough. Then there's a purpose of the class. Okay? Hello, Sharmila. Now, what are the applications of dimensional analysis? It helps you derive formulas. How? For example, the question is, derive the formula for time period t of a simple pendulum. Okay? So, let's say, and in the question itself, they give you that t depends on length and acceleration due to gravity. Okay? This much is given. So, what I will do, I have to derive a formula for time period of a simple pendulum, and I will say this time period is proportional to the length into some power, I don't know, into gravity also with some power. This is what is given to me in the question. Okay. So in the question it tells me time period is proportional to L raised to A and G raised to B. This much is given to me. I don't know A and B. It could be 0, it could be 1, it could be 2, it could be 5, it could be any number. And there could be constants also. That's why I put the proportionality. So when I remove the proportionality, I put a constant L raised to A, G raised to B. So why do I put the constant? See, students, sometimes there are equations. For example, kinetic energy is what? Half mv square. Half is a constant there. So I don't know if I have a constant here, so I will just put k. Sometimes k will be 1, but I don't know. Let me find out. Now what I will do is I will write down this whole formula in terms of dimensions. So let me do that. What is the dimension of time? T is equal to, what is the dimension of length? L raised to a. What is the dimension of gravity? Acceleration, same dimension. Lt raised to minus 2. The whole raised to b. Okay. Yeah. So t, I know t is raised to 1. Right, because the dimension for time is t raised to 1. So now what I will do is I will equate this whole thing. So, okay. So t raised to 1 is equal to L into L raised to A into L raised to B. So this is basically L raised to A plus B. A raised to M into A raised to N is A raised to M plus N. And then T raised to minus 2B. Isn't it? Minus 2 into B. Minus 2B. Now I will equate the powers. So what is the power of T? T is raised to 1. So, I will take t alone. So I have t raised to 1 is equal to t raised to minus 2b. So 1 is equal to minus 2b. b is equal to minus 1 by 2. Yes. Now similarly, I don't have L on the RHS side. So it's 0. So L raised to 0 is equal to L raised to a plus b. So from this I will get 0 is equal to a plus b. So a is equal to minus b. So a should be what? Minus 1 by 2, which is 1 by 2. Okay. So now I have my formula. I have my formula. T is equal to K. What was my initial formula? K L raised to A G raised to B. So this is now K L raised to A is 1 by 2. G is minus 1 by 2. So this now I can write it as K L by G, the whole raised to 1 by 2. Can I do that? Because it's G raised to minus 1 by 2. Now this is what? K into square root of L by G. So my formula is T is equal to K into square root of L by G. This is the formula for time period of a pendulum. Okay? Yes? Yes. So dimension formula can be used to derive formulas. Okay? Yes, Praveen, that's right. That's the same thing that we got. We got that time period is directly proportional to square root of length and inversely proportional to the square root of acceleration due to gravity. Yeah. Okay. Next question. Next question. Derive the formula for centripetal force F, assuming it depends on mass, velocity, and radius. Okay. How will I do that? First, I'll write down the formula. Centripetal force F is proportional to what all? It's proportional to mass raised to some power, velocity raised to some power, radius raised to some power. Now this I can write it as F is equal to, there could be a constant, ma, MA, VB and RC. Okay? Yes. Now let me write down have I solved this? Okay, I've solved this here, but I can solve it once again. That's not a problem. So let's write down the dimensions now. Okay, what is the dimension of force? Force has a dimension. Force is, okay. Force is mass into acceleration. So it is m Acceleration is lt raised to minus 2. So students, velocity, acceleration, all those dimensions you should know by heart, okay? Because you can't every time sit and derive. You will lose time. So force, the dimension is mlt raised to minus 2. Force is equal to, K I will ignore, mass has dimension m only, m raised to a, velocity has dimension lt raised to minus 1 raised to b, radius is length, so it has the dimension l raised to c. Okay. Now m l t raised to minus 2. First PUC is not tough, toxic. It's very easy. But you should study. That's all. M raised to A, L raised to B plus C, T raised to minus B. How did I get all that? Yes, this becomes L raised to B, T raised to minus B. There is L raised to C. So L raised to B into L raised to C is L raised to B plus C. Okay. Now what I will do, I will equate all the powers. The first, this is m raised to 1, L raised to 1. So first is m raised to 1 is equal to m raised to A. So A is equal to 1. Let me check. Yes, we are right. Okay. Next, L raised to 1 is equal to L raised to B plus C. So B plus C is equal to 1. I have two equations. I have A is equal to 1. I have B plus C is equal to 1. Next, T raised to minus 2 is equal to T raised to minus B. So minus 2 is equal to minus B. B is equal to 2. Yes, B is equal to 2. Okay. So now B plus C. B plus C is equal to 1. So 2 plus C is equal to 1. C is equal to 1 minus 2, which is minus 1. Okay. Now I have A, B and C. I have A, B and C. So now what is the next step? Next step is the most easiest step. Substitute onto the formula. So I will substitute purple. So F is equal to K times M raised to A is 1. V raised to B is how much? 2. R is minus 1. So this will be KMV square. R raised to minus 1 is R. So it is MV square by R. So the force will be F is equal to half MV square by R. Okay? Yes? Students, is this clear to all of you? So those who are wondering what I'm doing, I'm actually I'm equating the powers. So M raised to 1 and M raised to A. Then is here. And then L raised to 1 to L raised to B plus C. Also like that. Okay? So quickly students, can you let me know if this is clear to you? This is all very important. Okay? Now there are some limitations to dimensional analysis. See, there is no uniqueness. See, ma'am, what's your name? My name is Catherine. Okay? So if you look at the thumbnail, my name is there. Catherine. Okay? Yeah. Please tell all your friends that there is a physics teacher. Her name is Catherine and she teaches on Vedantu, Karnataka. And please watch her videos. Okay? Please do tell all your friends. Okay. If dimensions are given, the physical quantities may not be unique. And it does not give you information about constants. So as I said, all the formulas we can get, but you can't find out the constants. And it helps you, it cannot be used to derive, say, trigonometric equations, logarithmic equations and all. and it can't handle too many variables. So M, L and T is fine, but if you have so many, it's very difficult. Okay, and it does not give you the vector direction. These are all things. Okay, next, final and most important part. I mean, everything is important, but one major part of this chapter is significant figures. Okay, so significant figures is also very important. Significant figures and errors are very important when it comes to KCET point of view as well. So significant figure is basically the number of digits that are significant. Okay, so in any number, there are certain digits that are significant, certain digits that are not significant. So the ones that are significant is significant figures. Let's look at some examples. 52.3. 52.3 has three significant figures. But 0.00450 also has only three significant figures. 100 has only one significant figure. 100.0 has four. So this is very confusing. How do you determine significant figures? So what you do is there are some rules to identify significant figures. Let's look at the rules. Rule number 1. All non-zero digits are significant. For example, 3, 5, 6, 7, 9. How many significant figures? 1, 2, 3, 4, 5. 5 significant figures. 1, 2, 3. How many significant figures? 3 significant figures. Okay. So all non-zero digits are significant. Next question. Next rule. Zeros between non-zero digits are significant. For example, 1, 0, 2, 0, 3. Now zeros are between two non-zero digits. So here 1, 2, 3, 4, 5. This is 5 significant figures. 101. 3 significant figures. 1001. Again 4 significant figures. So if a zero is between two non-zero digits, then they are significant. Next, leading zeros are not significant. For example, 0.025. This has only two significant figures. 0.0004 has only one significant figure. 0.0023. This has two significant figures. So if zeros are before a decimal and before a number, which means the zeros are first and then you have the number, then those are not significant. Next one, trailing zeros after decimal point are significant, like 2.300. This has four significant figures. If you have 5.61234, then this has 1, 2, 3, 4, 5, 6. 6 significant figures. So if 0 is after the decimal, it is significant. Next, zeros in a whole number without a decimal are not significant. For example, 50,000 has only one significant figure, but 5.123, can you see? 5.123 will have 4 significant figures. Okay? Yeah, this is very easy. If you look at the rules and examples, you will get it. Next, exact numbers. Exact numbers, like say you have 100 apples. So 100 apples means what? 100.000. How many ever zeros I can put. But zeros after a decimal are always significant. So this will have infinite significant figures. Okay. So for example, I say there is a dozen of apples. So how many apples are there? 12 apples. 12 means 12.0 or 12.0000. So this also has infinite number of significant figures. Okay. So for whole numbers, they all have infinite number of significant figures. Now what about powers? So for example, 3.00 into 10 raised to 8. This has only 3 significant figure. You ignore the power. 6.022 into 10 raised to 5 has only 4 significant figures. 1.0 into 10 raised to minus 2 has only 2 significant figures. The powers you can ignore. Okay, quick exercise. All of you pause the video, find the number of significant figures. Or you take a screenshot, find the number of significant figures. Yes, I think you've done it. Now you can check with your answers. The answers are here. Okay. Yeah, the answers are here. Okay, let's move on. Next is rules for rounding off significant figures. Look at this question. First rule is what? If the digit to be dropped is less than 5, leave the last digit unchanged. What does that mean? If the digit, so 3.52, the question asks you to round it to 2 significant figures. Okay, so you need to have only 2 numbers. So you look at the last digit. Which is the last digit? This is the last digit. So you have to look if it's less than 5 or greater than 5. It's clearly less than 5. So you ignore it. So the answer is 3.4. Now imagine this was 3.45. Okay. So look at you need to convert it into 2 significant figures. Look at the last number. It's greater than 5 or equal to 5. Okay. Now if it's equal to 5 also, you can drop it. It becomes 3.45. But if it is greater than 5, then this becomes 3.5. How did that happen? I will round it to 4.625. Okay. So if the rule is, if the digit to be dropped is greater than 5, which means the last digit to be, whichever digit is to be dropped, if it is greater than 5, then the second last digit is retained by increasing it by 1. Look at these examples. Now, the number is 9.947. I want to round it to, let's say, 2 significant figures. Okay. So, I need to get it as 2 significant figures. So, 947. So, obviously, I have to ignore this. But now, this is the digit that I have to look at. 4 is less than 5. So, I can just ignore this as well. This becomes 9.9. But if I have to round it to 3 significant figures, then this is the last digit that I have to look at. So this is greater than 5. So I remove it, but I add 1 to this. So this becomes 4 plus 1, which is 9.95. Okay. So are these rules clear? So if the digit to be dropped is less than 5, leave the digit unchanged. If it's greater than 5, add 1. If it is exactly 5, then leave it. Okay. Okay. Next is operations with significant figures. So there are some operations with significant figures like multiplication and division. So if you multiply 2.5 into 3.42, then what you will get? You will get 8.55. But you will write the answer in 2 significant figures. Why? Because both of your numerators, in both those values, you look at the number with the least number of significant figures. Which one is it? It is 2.5. Okay. So 3.42 has 3 significant figures. 2.5 has 2 significant figures. So that means your answer should only have 2 significant figures. So look at the last digit. It is equal to 5. So you can just drop it. So the answer, it will be plus 1. So this will be 8.6. Okay. Even in the case of division, the lowest number of significant figures should be there for the answer. Even for addition and subtraction, you add the 2, round it to the lowest number of significant figures. Okay, there is an exercise here. Quickly pause it and do it. Yes, I have the answers also here for you. Okay, now next is least count. So least count is the smallest measurement that can be taken accurately with an instrument. Okay, for example, if you have a scale, what is the smallest measurement you can take on that 15 centimeter scale? It is 0.1 centimeter, right? The smallest line. So if you have the scale, the first line, the smallest first line is what? 1 mm or 0.1 centimeter. So that is the least count of the scale. Similarly, for different devices, the smallest value you can measure is its least count. Example, if a ruler has divisions of 0.1 centimeter, you cannot measure anything smaller than 0.1. So that is its least count. Now here, look at this. This is the screw gauge, the least count of a screw gauge. So least count is pitch by total number of divisions on the circular scale. So you can see on the screw gauge there are two scales. This is the circular scale and this is the main scale. Okay. So least count is 1 by 100. So pitch is the distance moved by one full rotation, which is usually 1. Okay. And then you divide it by 100, you get the least count. This is mainly for your practicals. For your PU practicals, you need to know what least count is. Okay. Similarly, for a vernier, you can find out the least count by taking the least value. So it is usually 1 mm minus 0.9 mm, which is value of one main scale division minus value of one vernier scale. So you can see there is a main scale and there is a vernier scale. If you subtract the values, you will get the least count. Next, very important topic, errors. Wait, I think I should explain this a little more properly. So look at this main scale. Okay, I can't change. Hi, Sharmila. Yeah. Look at the vernier scale image. Okay. Yeah. So the value of one main scale division minus value of one vernier scale. So there's a main scale and a vernier scale. So if you subtract the smallest values of those, you will get the least count. But main scale division, you know, you can see. Okay, so it is just 0.1 centimeters or 1 mm. It's like a normal scale. But vernier scale division, how will you do? Number of vernier scale divisions is basically the length of the vernier scale divided by total number of divisions. So the length is 9 mm divided by there are 10 lines. So 9 by 10, 0.9. Okay. So when you go to your lab, you can take a vernier scale, take a screenshot of this, go to your lab, take your vernier scale and check for this. Okay. Yeah. So errors. What is error? When there's a difference between the actual quantity and the measured quantity. For example, again, I'm going to use the pen. So if this pen is 5 centimeter long, but when I measure it, I get it to be 4.8. So there is an error there. How much is the error? It's about 0.2. Okay. So errors, there are so many questions I've seen. I mean, every year I've usually seen one question from errors in your KCET exams, KCET. So listen carefully. Okay. Absolute error is true value minus measured value. So you just subtract the values. Now percentage error is absolute error divided by true value into 100. That will give you the percentage error. Now, this is the important part of error. You can either add or subtract errors. But how will you do that? So imagine Q is equal to A plus B or A minus B. Now to add or subtract the errors, what you do is you take delta Q, which is the error in Q, times delta A plus delta B. This is how you find out the errors. Now in the case of multiplication or division, what you will do? So if Q is equal to AB or A by B, then delta Q is equal to delta A by A plus delta B by B. So this is the formula to find out errors. Okay. Just a second, students. Is this formula clear? So now, there are so many questions in KCET where they ask you to apply these formulas. I will show you some questions. Hmm. Yes. Now, if you have a constant, okay? So if you have a constant like Q, and Q is what, the constant is K. Q is K into A. Now, when you find the error, delta Q will be same constant into the error. Now, imagine there is a power, okay? Let's say Q is equal to A raised to N. Then delta Q by Q is equal to N into delta A by A. Students, all these formulas you should know. Okay? Okay? Let's look at a question. Then it will be a little more clear to you. We'll finish in another 10 minutes. Okay? So the question is, let's say there is a rod of length L equals 2 plus or minus 0.1 and breadth is equal to 3 plus or minus 0.2. Calculate the area and the error in area. Okay? So how you will do this? First thing, you will find out the area. What is area? Length into breadth. So 2 into 3, which is 6 is your area. Now how will I find the error in area? So error in the area will be del A will be equal to del L plus del B. Del L by L plus del B by B, del A by A. Yes, so it is going to be. So, this is going to be equal to del L is how much? 0.1 divided by 2 plus 0.2 divided by 3. So, this is going to be 0.05 plus 0.067, which is 0.117. Okay. So del A by area is 6 is equal to 0.117. So del A is what? 6 into 0.117, which is 0.7. So the final area is 6 plus or minus 0.7. Okay? Yes? No? Is this clear to all of you? Now we have one more question, same kind. So let's say you have three quantities. So this question will be, no, I've just put max here, but in your exam they say there is a cube which has three sides. Side A is this much, side B is this much, side C is this much. Find the volume. So what you will do? I will just here, since the question is Q, I will put it as Q. So delta Q by Q is equal to delta A by A plus delta B by B plus delta C by C. And then you just substitute the values. You will get the answer. Okay? Next question. A rectangular plate has the following dimensions. Calculate the volume, the absolute error. This you should be able to do by yourself. I have already put the answer here, but you should be able to do by yourself. Yes? Okay. Yeah, so that is So that's about errors. So students, so similar questions I've seen in so many KCET question papers. Okay. So you need to know how to do this. Now one more thing here. Imagine you have a power. So imagine this is B square. Okay. So you will just put 2 in here. That's the only difference. Imagine the formula is A into B square into C. So you will put A plus, 2B plus delta A by A plus 2 into delta B by B plus delta C by C. That's the only difference. Okay. If you don't want that, if it's not there, you don't have to do that. Alright. So students, that's the most important part of first chapter, which is units and measurements. I've solved almost all the questions, but some questions I've given it for you to solve. Okay. So please follow the class. Okay. We will be doing a whole series. We will be doing different chapters of first PU and second PU. We'll be doing 2 series simultaneously. One series of first PU chapters, the other series of second PU chapters. Alright. And all those who are in Bangalore or in Karnataka, please make sure you visit one of our offline centers. And where is our offline center? It's at JP Nagar. Okay. Where in JP Nagar? It's on the second phase. Okay. Building number 822, third floor, 24th main road, second phase, JP Nagar. We have a number here. If you have doubts on the location or anything, you can just give a call. Go visit our offline center. I am sure it will not be a waste of your time. Okay. Go visit once and then you can decide. Okay. You can decide what you want. Even if you don't want to join, I would just tell you, please go visit the center once. Okay. It'll be worth it. Okay. Do you trust me with this? All of you, please go visit the center once. And they will guide you on what you should do with your life and your career and whatever doubts you have. We have people there for you. Okay, we have taken a lot of effort to bring the best people for all of you. So please find out some time. All of you should visit the JP Nagar Center. Okay. Yes, I'm going because class is almost over. 30-second trending. Which last question, dear? This question is what you mean. So just like this question, I've done a previous question. Okay. I've done 2 questions. So if you just watch the recording, you'll see that it's exactly the same. Okay. So you can try to do this question by yourself by referring the previous question. All right. Yes. So it was very nice teaching all of you. Okay. So I will see you all in my next class. So students, if you've enjoyed this video, please let me know in the comments, like the video, subscribe, send it to all your friends, okay? Let them know that there is a teacher here who's teaching physics and help them also in their academics, okay? So I'll see you all in the next